Hello to everyone. My name is Bhagyashri Thorat and I am going to present a video lecture for IUCEE project Gentle Phase 2 on topic Simulation of Series Resonance Circuit in Multisim platform. So first go to start, type here Multisim. I am having a 30-day evaluation version of a Multisim from National Instrument. You can download this version from website as a student version, or in your colleges it is already purchased. So whatever convenient, you can download this on your laptop, or in labs it is already available. Go to the lab and try to perform this lab. So first, this is a Multisim window. This is your designing area. Design 1 is by default is there. So here file, edit, view, place, MCU, simulate, transfer, tools, reports, option, window and help. In a help you have all the information of this function. Today I am going to explain those functions which is required for simulation. Remaining functions you can study from net or using help documents. So first here, place basic components for series resonance circuit. So for series resonance circuit we require a resistor. Okay. Then we require a capacitor. We require an inductor. Click on OK. And the main, we require a power source. So basic change sources, power source, AC power, voltage source is there. Click OK. Close this window. Connect this circuit. When these two points are properly connected, this is red. Otherwise, if you see, this is black. So your circuit is completed, only ground is remaining. So basics. Here source, ground, OK, and place your ground here. Close this window. Just connect these 2 points. Now your circuit is connected. So it is your zero potential or zero first. This is your first node, second point, third point. This is your series resonant circuit. Now we want to edit the values of a circuit according to our convenience. If you want to zoom this circuit, you can zoom. Or you can select this circuit. So double click on this, change the value of your circuit. It is kilohertz. OK. Value of resistor 100 ohm. Value of capacitor value of inductor 10 millihenry. So this is the way you can simulate any series resonance circuit. You have to just double click the circuit, change the value whatever you require for simulation, click OK. For series resonance circuit, I already have one example. For this circuit, I calculated everything, that means resonant frequency, quality factor, every value. So this is a actual circuit for simulation. So R1 is a 40 ohm. R1 is very small because it is the internal resistance of your generator and internal resistance of inductor. So here IC is 0 ampere for inductor. Initially it is 0. Inductor value is a 30 millihenry. Capacitor is a 0.1 microfarad. IC is a 0 ohm. Voltage is a 565.68 millivolt RMS or 400 millivolt for simulation, and initial frequency is a 1 kilohertz and phase shift is a 0 degree. Remember this. Applied voltage is a 565.68 millivolt VRMS RMS voltage. Starting frequency of this source is a 1 kilohertz. R1 is equal to 40 ohm. Internal resistance L1 is equal to 30 millihenry. Capacitor is equal to 0.1 microfarad. If you want to change this name, go to label and resistor. So if you want to give only R, L, C, or for any specific problem you want to change resistor, inductor, capacitor, both ways are possible in Multisim. For simulation, I am going to zoom this circuit, maximize the area. That's why circuit is visible for you. Or so this is our circuit. To run this circuit, first go to simulate, then analysis, AC analysis, start frequency, which is your source start frequency 1 kilohertz, stop frequency 10 kilohertz, because for calculation of this example the resonant frequency is a 2.9 kilohertz, so stop frequency 10 kilohertz is sufficient. Sweep type is decade. Number of points per decade is a 1000 and vertical scale is, options are linear, logarithmic, decibel, octave. So we are going to select linear. For a very good visible graph, remember this setting. Start frequency is your source start frequency. Stop frequency, it should be greater than your resonant frequency. If you don't know the resonant frequency, you can give here stop frequency is a 1 megahertz. Sweep type decade, number of points per decade is a 1000 or it could be 10,000, but first see your graph and then decide these points. For 1 to 10,000, so 1 to 10 kilohertz frequency, 1000 number of points per decade is sufficient, and vertical scale is a linear. In output, you can see IC1 capacitor current, IL1 resistor, IV1, PC1, power across capacitor, power across inductor, power across resistor, power across V1, V1 and V2. So for this we are going to select V1, V2. If there something is already there, remove this. You can add this parameter V3 Analysis options are customize or use Multisim default. This is your summary. So from output, when you add V3, simulate. So this is your graph for series resonance circuit. Here is AC analysis, here magnitude of current, and here frequency response, and here phase shift of V3. So it is magnitude of voltage across V3. Now if you want to change the current, close this graph, simulate, analysis, AC analysis, output, change the parameter whichever you want to see the performance. It can be current C1, current L1, resistor, PV1, power across capacitor, power across inductor, or power across resistor. Series resonance circuit is work as voltage magnifier. So that's why we are taking V3. It is a voltage across inductor or the total voltage in a circuit. So simulate. Here your AC analysis and here your phase shift. Show cursor. If you press this show cursor, cursor is here, and you can move this cursor. See here, my cursor is here. Show grid. Select this graph, show grid. So that's why the grids are visible. Here, select a graph, show cursor. Select a graph, show cursor. Now if you want to change the background, I'm going to put this cursor, this reading box at this side, so that's why graph is visible. Then just change this. So this is series resonance AC analysis, and this is your phase shift. So for series resonance circuit, in a part 1 first lecture, we seen that before resonance frequency, circuit is a inductive. So that's why phase shift is greater than 0 degree. It is not plus 90 degree, it is below than 90 degree, because inductor is having internal resistance. And after FC, so this is my resonance frequency, it is 2.9. Similarly, here is my resonance frequency 2.9. See, at this is we are having a 0 phase shift. So from this simulation, this is inductive. Before resonance circuit, the series resonance circuit is an inductive circuit, and after series resonance circuit, the series resonance circuit nature is a capacitive. If you observe this graph, now I'm going to close the phase shift. Okay, this is series resonance. I'm going to zoom this graph. So again, simulate, analysis, AC analysis, and already we are having a setting, so directly this graph is here. So this is our series resonance graph. Change background first, and if you observe this graph, if you observe this graph, this is your FS 2.9. Calculate this FS. This is your homework. From 0 to FS, the graph is gradually increases because XL is gradually increases, and after FS, this graph is sharply decreases. So always remember, this graph is not symmetrical to FS. Before FS, it is gradually increases, and after this peak, it is sharply decreases. Always remember, series resonance is not having a symmetrical response at F1 and F2. So again, simulate, analysis, AC analysis, simulate. So on grid, show cursor. So this is your V3. I'm going to disable the phase shift graph because we just have to concentrate on this graph. Okay. So now here, see, I'm changing this cursor, and here the values are changing. So when this cursor is at 2.9, then Y2 is having a maximum value 5.4. So this is your I max. At 0.707 of Imax, you are having a F1 and F2. So here we completed our multisim simulation for series resonance circuit. At home, you are going to calculate F1 and F2 by using this graph, and try to comment on theoretical results, whatever you are going to achieve by using calculation of using these values: 40 ohm resistor, inductor 30 millihenry, capacitor 0.1 microfarad, and try to comment on what is the difference between theoretical and practical. So practically we are getting a less or 1 kilohertz difference or 100 hertz difference because of a simulation. Because simulation is in this, we are having a differential equation which is approximated to a particular degree, so that, but results are very near to actual results, so don't worry about this, and try to get the best or more than, at least try to simulate 2-3 examples by using this multisim for series resonance circuit. Then you can understand easily what is series resonance, what is quality factor, selectivity, phase shift, or the terms which are very critical if you only learn theoretically. So this is a very good platform, simulation. Similarly, you can perform this simulation in a Spice software. Those are very good in a Spice. Go for those software which are good, or you are having a very good experience from those software, or those are new, you can go for Multisim. This is, or Multisim help documents are available on net. So if you are facing any problem, you can have a discussion with me, or you can ask a question after this lecture. So thank you for listening series resonance circuit video lecture. So here we completed our one unit. It is series resonance. In this series resonance we are having a introduction, then circuit, series resonance circuit, frequency response of a VL, VC and VR, resonance condition, quality factor, selectivity. We solved some example on series resonance, and lastly we simulate a series resonance circuit by using Multisim platform. Thank you.